तो आज हम कंप्लीट करेंगे ब्लॉक 3। ब्लॉक 2 हो चुका था, ब्लॉक 1 भी हो चुका है, MCS-202 का ब्लॉक 3। इसमें भी 4 यूनिट है, जिसमें से 2 यूनिट अभी कंप्लीट करेंगे। 9, 10, 11, 12 में से 9 और 10 करेंगे, ठीक है। और MCS-201 का भी अभी पेंडिंग है, उसको भी कंप्लीट करना है। और पहला एग्ज़ाम उसी का है, ठीक है, MCS-201 का। तो जितना जल्दी ये मेरा कंप्लीट हो जाएगा तो हम आगे अपना पढ़ाई स्टार्ट करेंगे, ठीक है। बहुत स्पीड में ही करना पड़ेगा अभी। सो ये रहा 9, इसको हटा देते हैं। 9 में है क्या है, इंस्ट्रक्शन सेट आर्किटेक्चर, और 10 में है रजिस्टर, माइक्रो ऑपरेशन एंड इंस्ट्रक्शन एग्जीक्यूशन, ठीक है। तो जस्ट कंटिन्यू करते हैं अभी। इसमें हम लोगों को क्या क्या पढ़ना पड़ेगा, इंस्ट्रक्शन सेट कैरेक्टरिस्टिक्स डिज़ाइन कंसिडरेशन, ऑपरेंड डेटा टाइप्स, टाइप ऑफ इंस्ट्रक्शन, स्टोर प्रोग्राम ऑर्गेनाइजेशन, एड्रेसिंग स्कीम्स के अंदर इमीडिएट एड्रेसिंग, डायरेक्ट, इनडायरेक्ट, रजिस्टर एड्रेसिंग, रजिस्टर इनडायरेक्ट। ये शॉर्ट क्वेश्चंस में ये पूछते हैं, तो ये अच्छे से अभी करना पड़ेगा हमको, क्योंकि इसके बाद और टाइम नहीं है दोबारा से रिवीजन करने का। चलो स्टार्ट करते हैं। इंस्ट्रक्शन सेट आर्किटेक्चर, यस यही है। अ कंप्यूटर वर्क्स बाय फॉलोइंग इंस्ट्रक्शन, दिस टेल्स द हार्डवेयर व्हाट टू डू। इंस्ट्रक्शन these tell the hardware what to do. Instruction act as a bridge between the software and the hardware. The hardware is the physical computer architecture. The software is in the instruction set architecture, which is full list of instructions the computer understands to perform tasks. The ISA, instruction set architecture. Instruction set architecture. The ISA is how programmers communicate and control the computer. Instruction set characteristics and instruction format. Programs are written by programmer in assembly language which human can understand but computer cannot directly. Computer only understand binary 0 and 1, so that assembly instruction are converted into binary code instruction. Assembly language can only understand by human, computer cannot understand. So to understand the computer, assembly instruction are converted into binary code instructions so the machine to execute. Instruction format components. A typical instruction consists of 3 parts: operation code, OP code, operand and mode. Okay. OP code tells the computer which operation to perform, like addition and subtraction. Number of bits used to OP code determines how many operations can be represented. For example, 7 bits can represent 2 to the power 7 equal to 128 different operation. Operand, this is the data or the address of data on which the operation acts. The size of operand field depends on the memory address size or data size. Mode determines how to find the operand's address in memory. The mode bit can indicate direct and indirect addressing. Addressing modes. एड्रेसिंग मोड्स में क्या आता है, डायरेक्ट मोड एंड इनडायरेक्ट मोड। तो द ऑपरेंट फील्ड डायरेक्टरी कंटेन्स द मेमोरी एड्रेस टू द डेटा, एंड इनडायरेक्ट मोड द ऑपरेंट फील्ड कंटेन्स द एड्रेस ऑफ अ मेमोरी लोकेशन दैट स्टोर अ इफेक्टिव एड्रेस ऑफ डेटा. Once again, the operand field contains the address of a memory location that shows the effective address of data. Example from the text. The instruction format in the figure has 7 bit of OP code and 24 bit of operand address. Which figure it is talking about? Let me check it out. एग्जाम्पल ऑफ द टेक्स्ट ये छोड़ता है, आगे बढ़ते हैं. ऑपरेंड डेटा टाइप इन कंप्यूटर्स. ऑपरेंड डेटा टाइप्स. Operands are the data bits on which operation are performed by computer. Types of operand data. Types of operand data: logical data, boolean, represent true and false, usually stored as 1 or 0, used in decision, comparison and control flow. Data integer. लॉजिकल बूलियन ओके नेक्स्ट क्या है लॉजिकल डेटा टाइप्स बूलियन हो गया इंटीजर डेटा टाइप whole number without fractions can be further divided into decimal integer regular number fixed point numbers number with a fixed number of digits after the decimal used in precise calculation floating point number with decimal points that can move used for very large and very small numbers. Character data represent letter, digit, symbols and special characters stored using encoding standard like ASCII, American Standard Code for Information Interchange, codes characters using 7 and 8 bits. Unicode, a universal standard that can represent characters from many languages worldwide. Addressing schemes. Addressing schemes. Addressing modes are ways a computer instruction can specify where to find its operands, the data it needs to work on. Different modes gives programmers flexibility to write instruction efficiently. What is implied addressing mode? The implied mode, the operand is not explicitly mentioned in the instruction, instead the instruction itself implies with operand to use. The operand is usually a special register inside the CPU that the instruction automatically uses. Example, CLPA meaning why is implement mode useful? Simplified instruction since you don't have to specify operands explicitly. Why implement mode useful? Simplifies instruction since you don't have to specify operands explicitly. Faster execution becomes the CPU directly work with known registers used for operations on a special purpose register like a accumulator. Immediate addressing mode. In immediate addressing, the operand itself is the part of the instruction and यहाँ पे क्या था in implement the operand is not explicitly पहला में मतलब addressing scheme के अंदर implement addressing operand is not explicitly mentioned in the instruction and यहाँ पे क्या बोल रहा है in immediate addressing the operand itself is the part of the instruction. This means the instruction directly contains the value data to be used. The operands is called immediate operands because it's given immediately in the instruction. Example. Why is immediate addressing useful? It is useful when you want to initialize a register with a constant value. The operation is fast because the data is already inside the instruction. No memory access is needed to fetch the operands. Real life example immediate addressing का imagine you are baking a cake and you have a recipe card which is instruction. The recipe says add 2 cup of sugar. The exact quantity 2 cup is given right on the card. The recipe card is instruction quantity 2 cup immediate operands data directly given to the instruction. You don't need to look anywhere else to find how much sugar to add. It's written directly on the recipe. Okay, relating to immediate addressing. In immediate addressing, the computer instruction contains the exact value needed. Just like you don't need to search for the sugar quantity, the CPU doesn't need to go to anywhere else for the operands. It is already inside the instruction. Summary: real life recipe says add 2 cup of sugar, the value is immediate. Instruction said load has 20, the value is immediate. Okay, this is in real way explanation, and according to technical word we can say this. Okay, now need to find sugar amount, where else no need to find sugar amount anywhere else because it is says on the recipe card. So like no need to fetch operands from memory. Direct addressing, simple explanation. What happens? The instruction tells the computer exactly where to find the data in memory. The instruction tells the computer where to find data in the memory. The address in the instructions points to the memory location. The computer goes to the memory location and gets the data stored there. The computer goes to that memory location and gets the data stored there. Real life example: library book shelf. Imagine you are in a library where each book has a fixed shelf number. Okay, the instruction is like a librarian said, go to the shelf number 200 and bring that book. Here the shelf number 200 memory address, the book on shelf 200, data stored at the memory location of 200, right. The librarian directly goes to the shelf 200 and bring the book, the data. Bus computer example: loads AC, this loads means bring the data from the memory. AC is the register, a small fast storage inside the processor. 200 is the memory processes. The computer goes to the memory location 200, finds the value there 350, loads the value 350 into the register AC. Visualization कैसे करेंगे? What happens? Instruction says go to the memory address 200, means librarian go to the shelf number 200, and the computer goes to the memory location 200, means library goes to the shelf 200, finds data 350 stored at the location 200, मतलब find the book on the shelf 200, loads data 350 in register AC, bring book to you. Why is this useful? You can store many values in memory and the instruction just points to where the value is. You don't need to write the values itself in the instruction, just the address. Done. What is indirect addressing then? Okay. Indirect addressing. In indirect addressing, the instruction gives you an address. It's called the address A, but the address A does not contain the actual data. Instead, address A holds another address B, which holds the actual data. So you need two memory lookups: go to the address A to find address B, go to the address B to find the actual data. Real life example: two-step library book retrieval. Imagine a library where the librarian first gives you a note with a shelf number on it. You go to that shelf number, address A. On that shelf, you find another note with a different shelf number, address B. You go to shelf number B to get the actual book data. Computer example: the instruction says go to the memory location 200, address B. Memory location, go to the memory location itna, and memory location 200 holds the value 350, which is address B. Okay, memory location 350 holds the actual operands data. So load 10 in the register AC. Clear? ये मस्त clear हुआ है अभी. What happens? Instruction points to the address 200, librarian gives note to the shelf number shelf 200, memory goes at 200, contain 350, go to the shelf 200, find the note with this, go to the address 350 and get data 10, go to the shelf this and pick the book, load data 10 into register AC, you get the book and bring it to you. Summary: instruction directly given address of data, indirect gives address to the memory location where hold the address. मतलब डायरेक्ट तो डायरेक्ट ही दे रहा है, इनडायरेक्ट घुमा फिरा के उसको दे रहा है. इतना समझ में आ रहा. मतलब मेमोरी लोकेशन में जाओ, जाकर वहाँ से डेटा मिलेगा, और डायरेक्ट एड्रेसिंग में इंस्ट्रक्शन डायरेक्टली गिव्स एड्रेस टू द डेटा, और जो डेटा का एड्रेस वो डायरेक्टली नहीं देगा, पहले गिव एड्रेस टू द मेमोरी लोकेशन, फिर वहाँ से विच होल्ड्स द एड्रेस ऑफ द डेटा. डायरेक्ट एंड इनडायरेक्ट इंपॉर्टेंट है, एग्जाम में आ सकता है. What is register addressing? In register addressing, the operand's data is inside a register within the CPU itself. Okay, the data is inside the register within the CPU itself. The instruction directly refer to the register, not memory. The instruction direct refer to the register, not to memory. Register are small, but storage area in registers are small, fast storage area inside the CPU. This means real life analogy देखते हैं. Think of a CPU as a kitchen. The registers are like small balls on the kitchen counter holding ingredients. Okay, the registers are like a small bowl on the kitchen counter holding ingredients. The accumulator AC. Okay, accumulator. The AC is like the mixing bowl where you combine ingredients. The instruction LDR means take the ingredients from bowl R1 and put it into the mixing bowl. The bowl R1 has 201 grams of sugar. After the instruction, the mixing bowl accumulator will now have 201 grams of sugar. Summary: the operands is inside a CPU register. No memory address is required, so it is very fast. Instruction directly refer to the register. What happen in register indirect addressing? The instruction points to a register. That register holds a memory address, not the actual data. The computer uses the address to give to memory and get the real data. इसको फिर से करते हैं. The instruction points to a register. The register holds a memory address, not actual data. Okay. The computer use that address to go to the memory and get the real data. Then the data fetched from memory is used in the operation. Correct. Step by step instruction. Suppose the value is this, memory location contains the value of this. The instruction says loads the AC from the memory location address inside the R1 says go to the memory location 201. Memory address 201 has the value 175, so 175 is loaded into the accumulator. Simple analogy. Think of R1 is a pointer and address label. It does not hold the object but tells where to find the object. So instead of R1 having the object, it has a clue address about where the object lives. You first read the clue, then go to the location to pick up the object. Key points: R1 contains an address. This is why it is called indirect. You don't go to the data from R1 directly, you get the data first finding the address R1, then fetching the data from memory at the address. What is relative addressing? The effective address of operand is calculated by adding the value in the instruction called ADR to the current program counter. The program counter always points to the address of the next instruction to be executed. So the instruction tells the computer to look at the memory location that is certain offset away from the current AC. Step by step explanation. Suppose the instruction is at memory location 100, the instruction is LD 100 where ADR 100. When the processor fetched this instruction, the PC incremented to 102, assuming instruction size is 2 bytes. Effective address is equal to this become this. The operand is at memory location 202. Assume the value at memory location 202 is 130. The instruction loads 103 in the accumulator. What happen in simple terms? You say get the data is 100 places away from the current instruction. The processor figures out where the 100 places away location is adding 100 to the next instruction's address. Then it fetches the data from there. Real life analogy: imagine you are reading instruction to pick a book is in a huge library. The instruction says go to the shelf number 100 shelf after where you are right now and pick the book. Don't get the shelf number directly, instead you move relative to your current position. What is base register addressing? The instructions specify this. What is base register addressing? The instruction specifies two things: a base register which holds a memory address, an offset ADR or replacement value. The effective address EA where the operand is located is calculated by adding the base registers value and the offsets. इसको एक बार फिर से समझते हैं. What is base register addressing? The instruction specifies two things: a base register and offset which holds memory address or replacement value. The effective address EA where the operand is located is calculated by adding the base register value and the offset. The EA where the operand is located is calculated by adding the base register value and the offset. Explanation. Real life analogy. Imagine you are in a city with streets number. The base register is like the starting street number where to go, where you are. The offset is now how many streets ahead you have to go. So if you are currently at street 100 and you want to go 100 streets ahead, you end up at street 200. So imagine you are in a city with a street number. The base register is like starting street number where you are. The base register is like starting street number where you are. The offset is how many street ahead you have to go. So if you currently at street 100 is the base register and you want to go 100 streets ahead, you end up at street 200. You then pick something located at street 200. The operands. What is indexed addressing? The instruction specified the base address ADR. This is like the starting point or the beginning of data block. Base means base से समझ ही आ रहा है कि starting point or the beginning of a data block. An integer register, this holds an offset value. A base address, this is like the starting point or the beginning of a data block. An integer register, this holds an offset value. The effective address E is found by adding the base addresses and the value in the index register XR. This is very useful for accessing element is an array or a list where the base address is the start of the array and the index tells you which elements to access. Example, suppose you have an array starting at the memory location 100 and your index register XR contains 5. Instruction LD100 means load into the accumulator the value stored at address 100 plus ZR. This is example है. Real life example, imagine a book shelf. The book shelf start at position 100. The index register is like a bookmark telling you how many books ahead you want to look. Okay, the base shelf starts at position 100 which is base address, and the address register is like a bookmark telling you how many books ahead you want to look. If your bookmark says 5, you count 5 books from the start 100 which brings you the book number 105. You then pick that book from the shelf. Summary, index addressing lets you address elements in sequence like array efficiently. The effective address is the base address plus the index value. It provides flexible access to elements stored sequentially in memory. अच्छा, तो क्या है? Index addressing lets you access element in sequence like array efficiently. The effective address is the base address plus the index value. It provides flexible access to elements stored sequentially in memory. स्टैक एड्रेसिंग एंड स्टैक ऑर्गेनाइजेशन, स्टैक एड्रेसिंग एंड स्टैक ऑर्गेनाइजेशन देखते हैं मिनट्स। स्टैक एड्रेसिंग एंड, अच्छा स्टैक एड्रेसिंग में इसमें ऑपरेशन भी है, ओके ठीक है। तो क्या है स्टैक एड्रेसिंग एंड स्टैक ऑर्गेनाइजेशन? अ स्टैक इज अ स्पेशल काइंड ऑफ डेटा स्टोरेज ऑर्गेनाइज एज लीफो लास्ट इन फर्स्ट आवर। क्या बोल रहा है? स्टैक इज अ स्पेशल काइंड ऑफ डेटा स्टोरेज, स्टैक स्टोरेज, स्टैक इज अ स्पेशल काइंड ऑफ डेटा स्टोरेज ऑर्गेनाइज एज लीफो। Think of a stack like a pile of books. You put new books on top. When you take book, you always take the one on the top, the last one you placed. ये मतलब ऐसा हो गया कि स्कूल में जैसे हम लोग कॉपी सबमिट करना होता था, असाइनमेंट सबमिट करना होता था, तो जो लास्ट में आता था उसका पहले चेक होता था। ये उस तरह का है, समझ में आया? स्टैक एड्रेसिंग एक बार फिर से पढ़ते हैं ऊपर से। अ स्टैक इज अ स्पेशल काइंड ऑफ डेटा स्टोरेज ऑर्गेनाइज एज लास्ट इन फर्स्ट आउट। थिंक ऑफ अ स्टैक लाइक अ पाइल ऑफ बुक्स। यू पुट न्यू बुक ऑन द टॉप. When you take a book, you always take the one on the top, that last one you placed. The stack holds a limited number of words, data items. For example, 64 words in your case. Key components: stack pointer SP, a special register that always points to the top of the stack. The location of the location of the last item pushed. Data register DR holds the data to be written onto or read from the stack. Full flag set to 1 when the stack is full, meaning no more data can pushed. Empty flag set to 1 when the stack is empty, meaning no data is available to pop. Key components: stack pointer SP, a special register that always points to the special register that always points to the top of the stack, the location of the last item pushed. Data register holds the data to be written onto or read from stack. Full flag set to 1 when the stack is full, meaning no more data can pushed. Set to 1 when the stack is empty, meaning no data is available to pop. Push operation: adding data to stock. Before pushing data, the system checks if stack is full. If the stack is not full, the data to be pushed in place to the data register. The stack pointer is incremented to point to the next free location. The data is DR is stored at the location point by SP. Okay, real life example: imagine stacking book on a table. You place a book on the top of the pile, you means push. The pointer SP tells you where the top of the pile is. You cannot add more books if the pile reaches the ceiling. You cannot remove a book if there is none of the pile stack empty. Now यूनिट 10 देखते हैं, जिसमें क्या क्या पढ़ेंगे। रजिस्टर, माइक्रो ऑपरेशन एंड इंस्ट्रक्शन एग्जीक्यूशन से रिलेटेड, ALU ऑर्गेनाइजेशन, ALU डिज़ाइन, माइक्रो ऑपरेशन कॉन्सेप्ट्स, इंस्ट्रक्शन एग्जीक्यूशन एंड माइक्रो ऑपरेशन। Register, micro-operation and instruction execution. Registers are like your desk drawer inside a computer brain. Registers are like your desk drawer inside a computer's brain, means CPU. Register, small fast drawer right on your desk where you keep things you use a lot. Main memory, the bigger cabinet further away, slower to reach. Type of important drawer, registers. Type of important drawers, program counter, PC, instruction register, general purpose register, memory address register, memory buffer register, status registers. Sticky note that tells you which tasks to do. Program counter, a sticky notes that tells you which tasks to do, means which instruction. The current task written on your note that you are working on. The current task written on your note that you are working on. Instruction register. General purpose register, drawer where you keep temporary steps, numbers, results. Memory address, drawer holding the label that the cabinet drawer you want to open. Drawer where you put stuff you just look out or want to store. Status register, little light on your desk telling you if something special happened. Why registers? Registers are fast because they are right on your desk. Accessing memory is slower, like walking to the cabinet. You only need a small note, few bits to find things in your desk drawer, but a big map, more bits to find things in the cabinet. Summary with example. Imagine you are adding two numbers. PC points to the first note, get number from cabinet drawer 100. MAR holds 100 to find the drawer. MBR holds the number you found, say 10. You put that number in the desk drawer, register R1. Next you get the number from drawer 104 similarly into R2. You add the two numbers on your desk, R1 plus R2, store result in R3. Status light flag shows if addition was special like 0 or carry. Programmers visible registers, drawer you can directly open or use while working. There are four main types: general purpose register, data register, address register, condition code register. General, like your main desk drawer where you keep things, numbers, data or addresses, whatever you need at the moment. Data register, special drawer means to hold data values that you work with. Address register, drawers that holds location or addresses of where data is stored in the cabinet memory. So general purpose data में क्या है, like your main desk drawer where you keep anything, number, data, address, whatever you need at that moment. And data register, special drawer meant to be hold data values like numbers, characters that you work with. Or address register, drawers that holds location or addresses where data is stored in the cabinet memory. Condition code register, these are like small indicator lights on your desk showing results of operation. Example, if the last number was 0, negative, or if there was a carry in addition. Programmers use these registers directly to store data, addresses and track conditions during program execution. Micro operation, small step to execute an instruction. Micro operation is a tiny basic step that the computer's processors perform to carry out an instruction. Each micro operations happens in one clock cycle. Real life analogy, making a sandwich. Thinking of making a sandwich as a completing a task, it has many small steps. So micro operation means a small kind of operation, something small step to execute an instruction. A micro operation is a tiny basic steps that a computer processor perform to carry out an instruction. Each micro operation happens in one clock cycle. Real life analogy, like a sandwich. Think of making a sandwich as completing a task. It has many small steps. Get the bread, spread butter, add ingredients, assemble sandwich, serve the sandwich. Like fetch instruction from the memory, decode instruction, fetch operands data needed, perform the operation like add or subtract, store the result back to the memory. How a computer execute a simple instruction? Fetch instruction from memory, put instruction in instruction register, decode instruction, control unit figure out what to do. Fetch operands, load value of A from memory into the processor register AC. Execute, just load, no math needed. Store results, if needed, save back to memory. Type of micro operation: register transfer, moving data between register or between register, moving data between register and memory. Arithmetic micro operation, basic math operation like add, subtract, comma, increment. Logic micro operation like add or not. Shift micro operation, moving bits left or right, useful for multiplication or division. Summary: micro operation are tiny steps done in one clock cycle. They together completes a whole instruction execution. Register transfer micro operation, what? Moving data from one register to another or between memory and register. Example: copy the value from register A to register B. Real life analogy: passing a note from a friend to another. Register transfer micro operation, moving data from one register to another or between memory or registers. Copy the value from register A to register B, passing a note from a friend to another. Arithmetic micro operation, perform basic math operation on data in registers. Add, subtract, increment and decrement. Real life analogy: adding and subtracting money from your wallet. Logic micro operation, perform logical operation on bits in register. Example: and or not is logical operation, kind of and or. ठीक है. Real life analogy: switching on and off based on the condition. Shifts micro operations, shifts bits in a register left or right by one or more positions. Uses multiplying or dividing number by power of 2. Sliding a row of books to the left or right on the shelf. Instruction execution and micro operation in a very simple way. What happens when a computer runs a command? It breaks the command into tiny little steps. Each tiny steps is called micro operation. When you want to make a sandwich, you don't do it at all at once. You do steps like get bread, add butter, add jam, then close the sandwich. How does the computer know when to do each steps? The computer has a clock inside the act, like a timer or a teacher, telling it, now do this step, now do the next step. Example: a teacher says, open the book, then turn to page 10 step by step. Getting information from memory. Sometimes the computer needs to get info from its memory to work on it. Direct way: it knows exactly where to look and goes straight there. Direct way: it knows exactly where to look and go straight there. Indirect: it first look at the node that tells it where to find the real info, then goes there. Example: direct: you go straight to your favorite books on the shelf. You first check a list, then says which shelf your book is on, then go to that shelf. So indirect: you go straight to the favorite book on the shelf. Direct: you go straight to your favorite book on the shelf. Indirect: you first check a list that says which shelf your book is on, then go to that shelf. Register versus memory. Registers are tiny storage spots inside the computer that are very fast to reach. Memory is bigger but slower to reach. Example: register are like things on your desk, easy to grab. Memory is like a box under the bed, takes more time to get. Interrupt: when the computer has to stop and pay attention. Sometimes the computer is doing one job but suddenly something important happens, like you pressing a key or a printer asking for attention. The computer pause when it's doing, take care of that. Example, you are reading a book and your phone rings. You stop reading, answer the phone, then go back to your books. Simple summary. Computer follows many small steps to run an instruction. A clock tells the computer when to do each step. It fetches data directly or by looking up addresses. Registers are like your desk, fast to access. Memory is like a box, slower. Interrupts are like phone calls, they pause when you are doing. Instruction cycle. The instruction cycle is like the routine a computer follows to run one instruction. It has 4 basic steps. Fetch. Instruction cycle. The instruction cycle is like the routine a computer follows to run one instruction. It has 4 basic steps. Fetch. Get the instruction from memory, understand what the instruction want to do and execute to the actual work, like adding number, moving data and all these. Store, save the result if needed. Real life analogy. Making a cup of tea. You get the tea bag from the cupboard. We are fetching. You read the instruction on the tea packet to understand how to make tea. Means we are decoding. You boil water and put the tea bag in the cup. So it is executing. Think like making a cup of tea. When we get the tea bag from the cupboard, we are fetching. Reading the instruction written on this packet means we are decoding, and then start making tea, boiling water, it means we are going to executing. Store. You pour the tea in the cup and maybe add sugar and milk, okay. Then we store it into other cup. That means we are pouring it into the cup and maybe we can add any extra ingredients like sugar or milk or any other flavor we want to add. This calls store. In computer terms, the program counter PC tells the computer where the next instruction is in the memory. Program counter tells the computer where the next instruction is in the memory. The instruction is fetched into the instruction register IR. The CU decodes the instruction to know what needs to be done, and ALU, arithmetic logic unit, or other parts to do actual work. Okay? Arithmetic logic unit means just operations, like arithmetic operations kind of thing. The result may be stored back into a register or memory. After one instruction finishes, the PC moves in the next instruction and the cycle repeats. The instruction cycle is the step-by-step process the computer repeats to read and run each instruction in a program. Okay. Interrupt cycle in easy way. When a computer is running a program, sometimes it gets a signal called an interrupt. When computer is running a program, sometimes it gets a signal called interrupt. The computer need to pause what it is doing, handle the interrupt, and then go back to what it was doing before. The computer needs to pause what it is doing, handle the interrupt, and then go back to what it was doing before. What happens step by step? Save where you are means the whatever process it is processing, stop there, save the process whatever happened there. The computer save the address, the next instruction it will run, like bookmarking your page in a book. Go to interrupt task. It jump to a special program that handles the interrupt, like answering the phone or any other interrupting thing. Do the interrupt job. Yes, it runs the interrupt program like talking to the phone. Return back. After finishing, the computer return to the saved address and continues the main program, like going back to the bookmark page. Simple explanation. You are watching a video, program is running. Okay. Your phone rings, interrupts happen. You pause the video and answer the call, save address plus handle interrupt. When the call ends, you resume watching the video from where you paused, return to the save address. Summary of the interrupt cycle steps. Save PC to stack, remember where to return. Increase stack pointer, move to next empty spot in stack. Loads interrupts address, start interrupt program. What is instruction piping? Imagine an assembly line in a factory where different workers do different tasks one after another to build a product faster. इंस्ट्रक्शन पाइपलाइनिंग को समझने के लिए कैसे समझते हैं? Imagine a assembly line in a factory where different workers do different tasks one after another to build a product faster. Instruction pipelining is like that for a computer CPU. Instead of doing one instruction at a time from start to finish, the CPU breaks it into a small step and work on several instructions at the same time but at different steps. Imagine instruction piping is like that for a computer CPU. Instead of doing one instruction at a time from start to finish, the CPU break into small steps and work on a several instructions at the same time. But at different steps. How it works? Each instruction goes through several stages like fetch, decode, execute, memory access, write back. Get the instruction from the memory, understand what the instruction means, perform operation, read and write data if needed, save the results. In pipeline, while one instruction is in the execute state, another instruction can be decoded and yet another in fetch. This way, the CPU does many instructions simultaneously, speeding up the work. Real life analogy. Think of a making sandwiches. Person 1 gets the bread fetched, person 2 adds filling decode, person 3 executes, person 4 wrap the sandwiches, write back. Each person work on a different sandwich at the same time, making the process faster. Okay. Fast execution of instruction, better use of CPU resources, increase overall performance. Simple summary. Pipelining is like an assembly line for instruction in the CPU, allowing it to work on many instructions at once by dividing the work into steps. What is ALU? Arithmetic Logical Unit. ALU stands for Arithmetic Logic Unit. It is the part of the CPU that does basic maths like addition, subtraction and logic operations like and, or, not. It also do the shifting bits of moving bits left to right. How complex is an ALU? Simple ALU handle basic tasks like maths on whole number called fixed point number. More complex ALU is needed if the computer needs to handle decimal numbers with fractions, which require more steps and control. Fixed point versus floating points. Fixed point ALU works with whole number like 1, 200. It is simpler and faster. Floating points ALU works with numbers that have decimals like this is the more logic and spatial control to handle the decimal part. Spatial units for complex calculation. Some processors only have simple ALU for fixed point calculation. For complex tasks like floating points maths, they use spatial units called arithmetic processor. These are extra parts that help with complicated calculation. ALU does math and logic operation. Simple ALU, fixed math point numbers. Complex ALU or extra bit needed for floating point maths. What is What is arithmetic processors? Arithmetic processors were extra processors used in older computer to handle complex math calculation, especially floating points arithmetic numbers with decimals. Older main processors did not have built-in logic to handle these complex calculations directly. Why were they needed? Doing floating points math needs special complex hardware which is expensive and takes up a lot of space on the chip. To save cost, early computer did floating point maths using software which was slower. So companies created separate processors just the arithmetic task to speed things up. How does an arithmetic processor help? It can perform complex math operations like addition, subtraction, multiplication, division, exponentials, logarithm, and trigonometric functions faster than software routines. These makes program with lot of math run much faster and simpler. How is the arithmetic processor connected to the CPU? There are two main ways. Loosely coupled. The arithmetic processor is a helper machine. CPU sends data and instruction to it, does the math, then send back results. They communicate via special register and data transfer commands. Tightly coupled. Arithmetic processor act like a part of CPU itself. It shares register and instruction set with the CPU. CPU and coprocessor work closely together. The CPU fetches instructions and the coprocessor executes the math parts. Today's scenario, modern processors have built-in arithmetic units for both fixed point and floating points maths. So separate arithmetic processors are less common now, but the concepts help understand how complex math is handled efficiently. Analogy: think of a calculator app on your phone. The phone's main CPU handles everything, but when you open the calculator, it acts like a coprocessor specializing in maths. Sometimes it works separately, loosely coupled, sometimes feels like part of the phone system, tightly coupled. एक बार फिर से देखते हैं loosely coupled and tightly coupled में क्या है. Arithmetic processor is like helper machine. ठीक है. Arithmetic processor act like a part of the CPU itself. CPU sends data and instruction to it. It does maths and all these things. मतलब loosely coupled, the arithmetic processor is like helper machine, and CPU send data to instruction and do maths and all things. The communicate via special register and data transfer commands. Tightly coupled में क्या, arithmetic processor act like a part of the CPU itself. It act like a part of the CPU itself. And loosely coupled क्या बोल रहा था, is kind of a helper machine. Arithmetic processor is like a helper machine. Next है tightly coupled का, it shares register and instruction sets with the CPU. And फिर क्या है, CPU and coprocessor work closely together. The CPU fetches instructions and the coprocessor executes the math part. Okay, done with the ये 2 यूनिट हो चुका. नेक्स्ट हम पढ़ेंगे बाकी बचा हुआ 2 यूनिट जो कि ब्लॉक 3 में है.